Hey everybody, welcome back. So for this session, we're going to be looking at complex data types. So let's go ahead and jump into it. So first, let's go ahead and do a review of last session. So last session, we learned about variables and simple data types. Let's go ahead and do this review activity. So go ahead and pause the video. Try to accomplish these 4 tasks in Python and come back and we'll go over it. Okay, so we need to declare / initialize an integer, a float, a string, and then display the variables in the console. So we can go ahead and switch over to an IDE here. So first things first is the integer. So I'm going to call that I is equal to, and let's just say 2. It doesn't really matter what the number is, right? Python will understand that this is an integer because it is assigned an integer value. Next, we have the float. So f equals, and then this one will be 3.2. Right? As long as it's a decimal, Python will recognize it as a float. And lastly, we have a string. I'll just call it s is equal to, I'm going to put a single quote, but a double quote is okay, but single quote, and then string. Okay, so we've got declared, initialize, integer, float, and string, and now we have to output them to the console. So last session, we saw the print, right? So we can just pass these into the print. And this, we'll see down here in the console, 2, 3.2, and string, right? Totally fine. Something that I'd like to introduce is the f string formatter. So I'm going to remove these for a second. So let's say you wanted to have your variables all on a single line, not kind of on separate lines like it is in the console right now. So what you can do is create a variable output equals, and then you're going to use the lowercase f. After the lowercase f, you're going to put your quotes. And now, because that f is right next to that quote, it'll attempt to format what's inside this string. And we can use curly brackets to indicate Python code in this string. And then Python will interpret this and give you the right values. So let's go ahead and try that. So let's say I want to go I, F, and S separated by commas. So I'm going to use curly brackets. So curly brackets. And inside, I'm going to put I. Then comma, curly brackets, F, comma, curly brackets, S. Okay. And then print output. Run. And there we go, 2, comma, 3.2, comma, and then string. So this F formatting of a string is very helpful and it's very flexible as far as getting code, getting your variables or getting Python logic out into the console. So I would suggest using this F formatter going forward. And the nice thing too is that you don't have to do a variable. I just did this to show you the steps. You can actually take this, delete this, and put it directly into the print like so. And it'll run exactly the same. So I would suggest this. That's just my 2 cents. Feel free to look up, outputting in Python. There's probably a half dozen ways to do it. I just find this one to be the simplest. Okay, so now that we've gotten that squared away, let's go ahead and get into the topic for this session, which is complex types. So complex types, aka non-primitive, aka data structures. So we got 4 of them that we're going to look at. So we got lists, tuples, dictionaries, and sets. So lists are mutable, which are changeable sequences used to store collections of data. So think of it like a bag, and you can just throw stuff into the bag, and it will hold it all for you. Tuples are immutable, meaning they are non-changeable sequences used to store collections of data. So the definition for a list and tuple are very similar. It's just one is changeable, one is not. So like I said, the list is like a bag. You just throw stuff into it whenever you feel like, and it'll hold on to it. Tuples are like, you have a bag, you throw stuff into it, and once you're done throwing stuff into it, it locks. You can't throw any more into it. So they're not changeable. A dictionary is a mutable mapping of key value pairs, and a set is a mutable, unordered collection of distinct objects, meaning you can't have duplicates in it. So first one we're going to cover is lists. So lists, like I said, can pretty much hold whatever. They can hold text, numbers, booleans, etc. They do not have to be of the same type, right? So you can throw literally, anything like names, ages, other data structures, like they can all be inside the same list. It's generally a good practice to make the names of lists plural. And lists are indicated by square brackets in Python. So here in the screenshot, we've got our first line there, which is names equals, and then just an empty pair of square brackets. This is declaring an empty list. The second one there is names equals square bracket, and it's Will, comma, Tim, comma, Bob, comma, and Susan, right? So I have a list of names, and each element in a list is separated by a comma. That's how we know which element starts and when it ends. So how do we read information from a list? So you're going to have to use what's called the index. So the index is the position of an element in the list. Now, contrary to how you probably think in real life, indexes start counting at 0. So if we were to take a look at that screenshot there, on line 1, we've got the names list, and then we have Will, Tim, Bob, and Susan. So Will is at index 0. Tim is at 1, Bob is at 2, and Susan is at 3. So if I wanted to access each name, right, I would just say names, square bracket, and then whatever their associated index is. So on line 2, I'm saying, all right, the first variable, so first name in that list, is equal to names square bracket 0. And that's going to give me whatever the name is at index 0 and assign it to the variable first. On line 3, I'm saying, all right, last, the new variable, is equal to names index of 3. So give me the index 3 and assign it to the variable last, and it just happens to be the last element in that list. And then print them out, and you can see here I get Will and Susan. So that's how you access things in a list. When it comes to modifying a list, it's going to be using that same bracket notation. The difference is, though, is that we're going to be assigning something to it. So think of it like overriding something that already exists. So line 1 here, we see names equals Will, Tim, Bob, and Susan. On line 2, I'm saying index of 0 is equal to Mary. So that means that whatever previously existed at index 0, which currently is Will, I am overriding it with the value Mary. So that on line 3, when I print out names, notice Will no longer exists, and it is now Mary at index 0. So that's how you modify a list. So what do we want to add to a list that already exists? So lists, like strings, have built-in methods or functions. So to add elements, we're going to be taking a look at 2 of those methods. The first one is the .append, and this is going to add an element to the end of the list. So in the screenshot here, we have our names on line 1, and on line 2, I'm saying names.append Jerry. And what that's going to do is going to say, all right, take the element Jerry and tack it on to the end of the list right after Susan. The second method is .insert. So this is going to add an element at a specified index. And then once it inserts it at that specified index, the element that was already there and everything after it will be shifted 1 to the right. So we see an example of that on line 3. So names.insert at index 1, comma, so that's separating the 2 things. The first one is the index, comma, and the second part there is the element you wish to insert, which in this case is Mary. So I'm saying insert Mary at index 1. So that means that it's going to go from 0, so Will. Next is Tim. So Tim's at index 1. Mary is going to be inserted into index 1, and Tim, Bob, and Susan are going to slide 1 to the right. So on line 4, when I print them, you can see that's exactly what happens. So Will, Mary, Tim, Bob, Susan, and Jerry. And lastly, how do we remove something from a list? So there's actually a few ways to do this. There's a couple of built-in methods that are available to you. So the first one is pop, and I think that's probably the simplest. It's going to remove the last element or an element at a provided index if you pass one into those parentheses. And it returns it. It means it gives it back to you. So we can see examples of that on in the screenshot here on that second and third line. We have n1 equals names.pop. So what that's going to do is it's going to remove the last element and give it back. So that means that Sarah would be removed from the list, and then N1 would be assigned the value Sarah, since that's the element that got popped off the list. And then the line right after that, which is N2, is equal to names.pop1. So that's going to remove the element at index 1 and give it back. And in this case, it's going to assign it to the variable n2. The next method to look at is the dot remove. And this is going to remove an element by its value. Okay, so not by its index. And one thing to note about this function or method is that it only removes the first occurrence of an element. So if you have a list that has duplicates, it's only going to remove the first instance that it finds. So we see an example of that on the fourth line there. So names.remove and then Bob. And this is going to remove Bob if that name is found in the list. And lastly, we have a Python built-in keyword, which is del, which stands for delete. You can use that plus the index to just straight up delete an element from the list. So we see that in that last line in that screenshot. So del space the names list and then index 0. And that's just going to straight up remove the element at index 0. So you can see on the second screenshot there, kind of if you printed N1, N2, and names after all this is said and done, you'd get N1 equals Sarah, N2 equals Amy, and then the list ends up looking like Tim and Susan. All right, so let's go ahead and do a review activity. Feel free to pause the video, take a stab at doing this activity, and then come back when you're done. Okay, so let's go ahead and do this together. So I'm going to go ahead and copy this. I'm going to throw it into here. And then I'm going to highlight everything here and use on Windows or Ubuntu, it's going to be Control and then the slash to make them all comments. On Mac, I think it's going to be Command slash. All right. So first, create a list of car manufacturers, and let's just say 3 of them. So MFGS equals, and then I'm going to use some short names. So BMW, let's just say Audi, and GMC. Okay, add a new car manufacturer to the end of the list. So in this case, MFGS dot append, right? Because append is going to tack it on to the end of the list. And in this case, I'm just going to say Ford. All right, add a new car manufacturer to index 2. So in this case, we want to specify where to insert, right? Or in this case, just insert at index 2. And in this case, let's think of another car manufacturer, VW, so Volkswagen. Okay, display the car manufacturer at index 3. So to display, right, we want to print, and then we want to do index 3. So MFGS, and then square bracket 3. We now want to remove a car manufacturer. And then the next one after that is remove a car manufacturer and save it to a variable. So I'll try to use 2 different functions here. So first, let's just say del, right? We're going to straight up delete something by an index. So I'm going to say MFGS, and then we're just going to delete index 0. And then we have to remove it and remove one and save it to a variable, right? So in this case, I'm going to say car equals MFGS dot pop. Right? So if I leave it as is, it will remove the last element. If I pass an index, it'll give me a specific index removed and save it to the car variable. But let's just leave it as such. So I'm going to go ahead and, actually, I'm going to go ahead and print the end result too while I'm at it. So MFGS. Okay, so run. Okay, so we start off with BMW, Audi, and GMC. I then add Ford to the end of the list. I then insert VW at index 2. Okay, so at this point, let me go ahead and put a comment here. So at this point, we're going to have BMW, Audi, GMC, Ford's on the end, and then we inserted at position 2, VW. So this is what the list would look like at this point. So when we print manufacturers at 3, we get an output of GMC, which stands to reason because 0, 1, 2, and 3. We're going to delete manufacturer of 0. So that means this is gone. We're then going to pop with no index, which means the last element gets removed. So therefore, our output should be Audi, VW, and GMC, which is exactly what you see here. Great. So moving on to tuples. So tuples are similar to lists in that you can access things by index using that same square bracket notation. But you have to remember that they are immutable. They cannot be changed after they've been declared. So you declare them using parentheses. So in the example here, we got on line 1, names equals, parentheses, Will, Amy, and Tim. Notice here, same comma separated notation here as well for the separation of elements. On line 2, I'm printing the names. On line 3, I'm printing names of index 1. So in the output, you see the entire tuple and then the index at 1. Now, something to note here is that you'll see this commented code, and it says names of 0 equals Sarah. That will throw an error. You cannot do that. They are immutable. You cannot change them once they've been declared. Another thing to note is that if you have a tuple and it only has a single element in it, you have to have a trailing comma after its element. I actually don't have an example here, so let's go ahead and go back to the code. So let's just say I have a tuple, t is equal to, and in this case, if I only have one element, let's just say it's a, for example, okay, I have to put a comma here for it to be recognized as a tuple. And this is just something you have to remember when working with Python. So some helpful info. Here's a couple of links to W3 schools. So the first one is for lists built-in methods. The second one is for tuple built-in methods. The tuples don't really have very much because they're not modifiable, but the lists do have a few. Another thing to note here is how to find the length of a list or a tuple. So we can use the built-in len function. So here in our screenshot, we've got a names list, and then we're going to get the names len variable is equal to the len of names, right? So that's the function I'm talking about right here. So len parentheses names. So whatever goes into those parentheses, it's going to give you the length. And then print names len, and it's going to be 6. So when it comes to len, it does start counting at 1. So that means that we have 1, 2, 3, 4, 5, and 6 elements, right? And that's why we get an output of 6. So there's something to be aware of. The len function is probably going to be very important. So I don't want these videos getting too long. So before we move on to dictionaries, I want to end this video here and start dictionaries in a separate video. So I'll see you then.